Okay, today we're looking at section 11.2, fairness and voting methods. So now that we've covered a variety of voting methods, discussed the differences and similarities, might be leaning towards one method or another. You'll need to convince the other founders of Imaginaria that your preference will be the best for the country. Will your collaborators approve the inclusion of a voting method in the Constitution, they will want to know that the voting method is a fair method. In this section, we will formally define the characteristics of a fair system. We will analyze each voting previously discussed to determine which characteristics of fairness they have and which they do not. In order to guarantee one ideal, we must often sacrifice others. So the first criterion we're looking at is the majority criterion. One of the most fundamental concepts in voting is the idea that most voters should be in favor of a candidate or a candidate to win, and that a candidate should not win without majority support. This concept is known as the majority criterion. With respect to the four main ranked voting methods we have discussed, plurality, ranked choice, pairwise comparison, and board account method, we will explore two important questions. Which of these voting systems satisfy the majority criterion and which do not? Is it always fair for a voting system to satisfy the majority criterion? Keep in mind, this criterion only applies when one of the candidates has a majority. Some examples we will analyze will be based on scenarios which a single candidate has more than 50% of the vote. So we're going to use the information in the table to answer the following questions. So first, which option is the winner when using plurality? Who has the most first place votes? So option A has 1, option B has 2, option C has 2, and option D has 1. So in this case, there's a tie between B and C. Which option is the winner when using ranked choice? Okay, so if we eliminate A, that means this becomes 1, 2, and 3, and that means B has 3, and B wins. Does the majority criterion apply? If so, for which voting methods? If any, did the majority criterion fail? It doesn't apply because there is not a majority candidate. Okay. All right. Next up. This is supposed to be 3. And this is supposed to be 1, and this is supposed to be 2. Not sure what happened. We'll use the information in the table to find the winner using each of the voting methods in parts 1 and 2. And then, so pairwise comparison. You have A versus B. A is preferred here and here. And B is preferred here, here, and here. So B is preferred by 3, whereas A is only preferred by 1. Now let's look at A versus C. A is preferred here, not here, here, not here, and here. So in that case, A is preferred by 3 of the 5, so A is preferred by more than C. So A head-to-head with C wins. And then A versus D. A is preferred here, and here, and here, and here. So A wins. Now let's look at B versus C. B is preferred here, and here, and here. So B beats C. And B versus D. B is preferred here, here, and here. And then lastly, we have C versus D. C is preferred here, and here, and here, and here. So C. So A has 2 points. B has 3 points. C has 1 point. And D has 0 points. So pairwise, B wins. B also has a majority of first place by having 3. Next, it says the board account. So let's go back here. So if they come in last place, they get no points. Third place gets 1. Second place gets 2. And first place gets 3. Place 2. And we add it all up. A gets 9. B gets 9. C gets 8. And D gets 4. So in this case, it's a tie between A and B. Does the majority criterion apply? If so, for which voting method did the majority criterion fail? Yes, it applies because B had a majority in this case. And it failed in board account because B is tied with A, whereas in pairwise, B wins. So while the board account method frequently favors compromise candidate over the divisive candidate, pairwise comparison will always satisfy the majority criterion, as the candidate with the majority of first place votes wins each pairwise matchup. While it is possible for the majority candidate to win by the board account method, it is not guaranteed, so the board account method fails the majority criterion. So board account violates the majority criterion. Let's go back here and look at this. You look at option A here. Wrong one. Look at option A here. 4 second places and a third place. And then look at option B, who tied A, had 3 first places and 2 last places. So you can see B is more divisive. You either love them or you hate them. You want them to win or you want them to not win. And that's what they're talking about with a divisive candidate. Whereas option A is kind of a middle of the road. They're not everybody's favorite, but they're not everybody's least favorite either. If you prefer the border method, you might argue that its failure to satisfy the majority criterion is actually one of its strengths. The majority have the power to vote for their own benefit at the expense of the minority. The border method is designed to favor a candidate that is acceptable to the population as a whole. In this way, the border count method avoids the downfall of strict majority rule known as the tyranny of the majority, which occurs when a minority of a population is treated unfairly because their situation is different from the situation of the majority. Next, we look at the head-to-head criterion. Another fairness criterion you must consider as you select a voting method for a imagined area is the Condorcet criterion, also known as the head-to-head criterion. An election method satisfies the Condorcet criterion provided that the Condorcet candidate wins the election whenever a Condorcet candidate exists. A Condorcet method is any voting method that satisfies the Condorcet criterion. You recall from earlier, and every election has a Condorcet candidate. The Condorcet criterion will not apply to every election. Also recall that a Condorcet candidate cannot lose an election by pairwise comparison. So, pairwise comparison voting method is said to satisfy the Condorcet criteria. To determine whether the Condorcet criteria applies based on a summary of the rank balance. Well, let's see. Pairwise. If I look at A versus B, I see that A is preferred over B by 3 people. B is preferred by A over 2, so A gets that win. And A versus C, again, 3 to 2. So A is better than, or A is preferred by more people than B or C. So A is a Condorcet winner. A Condorcet candidate. And it's also a majority candidate. Okay, let's look at this again. I'll use the summary of rank balance below to find the winner and determine whether the Condorcet criterion is satisfied with each of the following voting methods are used. Recall that option A is a Condorcet candidate. So in plurality, A has 3 first place votes, so A wins. And since A wins, yes, it is satisfied. The Condorcet criterion is satisfied. Ranked choice voting. Which would be basically the same as our Condorcet or head-to-head. So again, A wins. And yes. How about border count though? So 3 gets nothing. 2 gets 1. And 1 gets 2. 2, 3, 1. B wins. And it does not satisfy the Condorcet criterion. Because B wins, not A. A is the Condorcet candidate. A should win. So again, basically to summarize it, as far as Condorcet criterion, the only one that satisfies it is pairwise. Every other one violates the Condorcet criterion. Now let's bring up the mononicity criterion. Citizens of Imaginaria might be surprised to learn that it is possible for a voter to cause a candidate to lose by ranking that candidate higher on their ballot. Is that fair? Most voters would say absolutely not. This is an example of a violation of the fairness criterion called the monotonicity criterion, which is satisfied when no candidate is harmed by upranking nor helped by downranking, provided all other votes remain the same. Consider a scenario in which voters are permitted a first round that is not binding, and then they may change their vote before the second round. Such a first round can be called a straw poll. Now let's suppose that a particular candidate won the straw poll. After that, several voters are convinced to increase their support or uprank that winning candidate, and no voters decrease that support. It is reasonable to expect that the winner of the first round will also win the second. Similarly, if some of the voters decide to decrease their support or downrank a losing candidate, it is reasonable to expect that the candidate will still lose in the second round. So why do we call it the mononicity criterion? Well, in mathematics, the term monotonicity refers to the quality of always increasing or always decreasing. For example, a person's age is monotonic because it always increases, whereas a person's weight is not monotonic because it can increase or decrease. The only changes to the votes for a particular candidate after a straw poll are in one direction. This change is considered monotonic. So use our favorite large dog breed ballot summary below to answer the questions. And I do believe we have to go to the next page. Oh, no. So determine the winner of election by board account. So let's go. Board account. So fourth place gets no points. Third place gets 1 times 42. 1 times 53. 1 times 61, and 1 times 24. Second place gets 2 times 42. 2 times 53. 2 times 61. 2 times 24. And then we do the threes. 126, 159, 183, 72. Then we add our border scores up. And I get 373, 201, 337, 169. So it looks like Standard Poodle wins by board account. Suppose that the 61 voters in the third column increase their ranking of the winner by 1. Determine the winner by board account with the new rankings. And that's this now here. Increase this from 2 to 1, so this would be 183. So this would be 464. So Standard Poodle still wins. So does this election violate the mononicity criterion? No. Do you think the result of part 3 is true for border count and the mononicity criterion in general? I do. Why? Because in the border count, upranking a winning candidate is just going to increase the number of points they get. The number of points for the 61 went from 122 to 183. So it increases the total points, and thus they're still going to win. So let's use our favorite large dog breed ballot summary to answer these questions. Determine the winner by ranked choice. Okay. Okay, ranked choice. Standard Poodle has 42 and 24 or 66 first place votes. Golden Retriever has 53. Labrador has 61. And Bulldog has 0. Yep, we forgot something. Adding up, we get a total of 180. So a majority is 91. So we don't have a majority. So we drop the Bulldog. That means that this, and let's change to a different color. This becomes 2, this becomes 3. And that's the only changes. So the reality is nothing changes. So now we knock out Golden Retriever. That makes this become 2. This becomes 1, and this becomes 2. And that's it. So this becomes 114, which is enough. The ranked choice, Labrador Retriever. Okay, let's look at this again. We still need 91 for a majority. And our beginning numbers are the same. 66, 53. Oh, wait, no. Suppose that the 24 voters in the last column of the table increased their ranking to the winner by 1. So that makes this 1. Which means this would not be 1. So that's 42. That's 53. That's 85, and that's 0. Still not enough. And again, when we knock out Bulldog, nothing happens. So now we knock out the standard poodle. Well, this becomes 2 and 3. This becomes 3 and 3. So now we knock out the standard poodle. And this becomes 1. This becomes 2. And now we have 95 and 85. And the Golden Retriever wins. Does this election violate the mononicity criterion? Yes, it does. Do you think the result in question 3 is true for the ranked choice method and the mononicity criterion in general? Why or why not? Well, there may be cases where it is okay, but since there is definitely a case against, we assume it fails. So since we found one negative, we're just going to assume it's negative. So that brings us again to our table. As far as the mononicity criterion, we found that plurality, pairwise, and board account satisfy it, whereas ranked choice does not. That brings us to our next criterion, the irrelevant alternatives criterion. So we've covered a lot of voting fairness, but there's one last fairness criterion that you and the other Imaginarians should know. Consider this well-known anecdote that is sometimes attributed to American philosophers, Sidney Morgenbesser. A man is told by his waiter that dessert options this evening are blueberry pie or apple pie. The man orders the apple pie. The waiter returns and tells him that there is also a third option, cherry pie. The man says, in that case, I would like the blueberry pie. This story illustrates the concept of the irrelevant alternatives criterion, also known as independence of irrelevant alternatives criterion, or IIA, which means that the introduction or removal of a third candidate should not change or reverse the rankings of the original two candidates relative to one another. In particular, if a losing candidate is removed from the race or if a new candidate is added, the winner of the race should not change. The local animal shelter is having another vote by donation charity event. This time, a $10 donation, an individual can complete a ranked ballot indicating their favorite small dog breed from the ones provided: miniature poodle, Yorkshire Terrier, or Chihuahua. Use the summary ballots to answer each question. So determine the winner of this election by ranked choice. So adding everything up, we get a total of 130, which means 66 is a majority. Now here, 53, here, 35, here, 42. So dropping the Yorkshire Terrier, it has the least number of votes. This becomes 2, this becomes 2, this becomes 2, this becomes 1, this becomes 1, this becomes 2. And now I'm looking at 42 plus 24, which is 66, and 64. Chihuahua wins. Okay. Determine the winner of the election if poodles are removed from the ballot. And we still need a majority of 66. We're taking poodle away, so this becomes 1 and 2, and this becomes 2. So now we're looking at 53 plus 24 plus 11, which is 88, and then 42. So in this case, Yorkshire Terrier wins. Does the election violate IIA? Yes, it does. And we removed the poodle and we changed winners. Use the ballot summary below to answer the questions. So first, we need to figure out what we have here. 27, 30 is what? 27, 30, 36. So majority is 19. By board account method. So the 4s are 0 points. 3 is 1, so that's 9. That's 11. That's 7. That's 6. And that's 3. 2 is 2. So that's 6. That's 12, 14, 22, and 18. I'm simply multiplying 2 times 9, 11, 7, and so forth. And 1 is 3. We have 27, 33, 21, 18, and 9. Adding them up, I get 61, 50, 60, and 45. So who wins? Jim. Okay, so now let's determine the winner of the election by board account method if Michael Scott is removed from the ballot. No, we didn't need that. So now we're going to take Michael Scott out of here. That makes this a 3. 1, 2, 3. This is 3. 1, 2, 3. Okay. Let's change our color so we can have some contrast. Okay, so now there's only 3 places. So the third place finisher gets dropped off. Get rid of them. And now, second place gets 1 times the number of votes. 9, 11, 7, 6, and 3. And then we have 2, 18, 22, 12, and 14, and 6, 34, 39, double check that. 20, 34, 22, 36, 39, 29, 35. So Pam wins. Does this violate the IIA? And yes, it does. When we drop Michael Scott off, our Jim wins with Michael Scott. Pam wins when Michael Scott is dropped. So that violates the IIA. So looking at the 4 we looked at here and their irrelevant alternatives, we find that all of them violate it. So that brings us to, is there a voting system you could recommend for Imaginaria that satisfies all the fairness criterion? If there is one, it remains to be discovered, and it is not a voting system that is based solely on preference ranking. 1972, Harvard professor of economics Kenneth J. Arrow received the Nobel Prize in economics for proving Arrow's impossibility theorem, which states that any voting system either existing or yet to be created, which the only information available is the preference ranking of the candidates, will fail to satisfy at least one of the following fairness criteria: the majority criterion, the Condorcet criterion, the mononicity criterion, and the independence of irrelevant alternatives criterion. This theorem only applies to a specific category of voting system, those for which the preference ranking is the only information collected. There are other types of voting systems to which the impossibility theorem does not apply. For example, there is a class of voting systems called cardinal voting systems that allow for rating the candidates in some way. Rating is different than ranking because a voter can give different candidates the same rating. Instead of the 5-star rating system used by various industries or the thumbs up, thumbs down rating used on YouTube. Could there be a cardinal voting system that does not violate any of the fairness criterion we have discussed? It's possible, but more research should be done. And that finishes this section.